While private rocket launchers have been putting on a great show, the real race for humanity's future is happening just out of sight. This isn't just about flags and footprints anymore. It's a high-stakes competition for permanent territory, incredible resources, and the power to set the rules for our future in space. And at the heart of it all is an astonishing new goal: building a permanent, city-like base on the moon, powered by a nuclear reactor. This isn't science fiction. China has been clear about its goal to set up a major international research station on the moon before 2035, and the United States has just revealed its own bold response. NASA recently announced a major pivot in its Artemis program, fast-tracking plans to build a permanent American base on the lunar surface, powered by a nuclear fission reactor. This shift signals a new priority, moving from short-term visits to a sustained human presence. Today, we're breaking down the official plans, the mind-blowing technology, and the massive geopolitical stakes in this race to build a nuclear-powered home on the moon. The new reality, a new kind of space race, the Cold War space race, that symbolic duel between two superpowers, is long gone. Now, a new, much more complex competition is heating up, with the moon as the main event. This isn't about proving one ideology is better than another. It's about securing a strategic position on what experts call the high ground of the 21st century. The game has changed, driven by the realization that the moon holds trillions of dollars in potential resources and offers a strategic edge that could redefine global power for generations. At the center of this new reality is China's incredible rise as a space power. For decades, the United States was the undisputed leader in space. But China's rapid progress has changed everything. With a string of successful robotic missions, like the first ever landing on the far side of the moon and returning samples from that unknown territory, China has shown it's not just catching up. In some ways, it's setting the pace. The current NASA administrator, Jared Isaacman, has been direct, stating that the US is in a race with China. He and his predecessor have both voiced concerns that China could try to claim resource-rich areas of the moon for itself. This isn't just Cold War-era paranoia. Both nations have their sights set on the exact same prize, the moon's south pole. This region is believed to hold large deposits of water ice in permanently shadowed craters, where temperatures drop to hundreds of degrees below zero. This water isn't just for drinking. It can be split into hydrogen and oxygen, providing breathable air and, most importantly, the key ingredients for rocket fuel. Making fuel on the moon would completely change the economics of deep space exploration, since we wouldn't have to haul every drop of fuel from Earth's heavy gravity. Whoever controls the water, controls the fuel. And whoever controls the fuel, controls the gateway to the rest of the solar system. This is the new reality, and it has forced a direct and urgent response from the United States. China's ambitions, the International Lunar Research Station. China isn't hiding its lunar ambitions. It's a point of national pride and a core part of its strategic plan. The main goal is the International Lunar Research Station, or ILRS. This isn't just a small outpost, it's a massive scientific base planned for the lunar South Pole, designed for long-term autonomous operation with rotating astronaut crews. While the project is a joint effort with Russia, it's pretty clear that China is in the driver's seat. The ILRS is being promoted as an open platform, and China has been actively recruiting partners, framing the project as an alternative to the US-led Artemis program. More than a dozen nations have signed on, including Russia, Pakistan, Venezuela, and South Africa, creating a coalition with strong roots in the global south. The construction plan is methodical. The first phase of reconnaissance is already happening with the famous Chang'e robotic missions. Chang'e 6 recently brought back the first ever samples from the moon's far side. Looking ahead, Chang'e 7 is set to launch around 2026 to search for water ice at the South Pole, and Chang'e 8 will follow around 2028 to test key technologies for base building, like using lunar soil to 3D print bricks. The main construction of the ILRS is planned between 2026 and 2035. This will involve setting up a command center and essential power and communication systems. A crewed Chinese landing on the Moon is a key part of this plan, aimed for around 2030. But maybe the most crucial part of the ILRS is its power source. To survive the brutal, 2-week-long lunar night when solar panels are useless, a constant source of energy is a must. To solve this, China and Russia have announced plans to jointly build and install a nuclear reactor on the Moon between 2033 and 2035. This nuclear power plant is what makes a truly permanent, year-round human settlement possible. By 2045, the plan expands to a full research network, maybe with facilities at the equator and the far side, all connected to a space station in lunar orbit. This is the comprehensive, step-by-step plan that the United States now sees as a direct challenge. The US response: the nuclear-powered Artemis base camp facing China's fast and focused lunar program, the US has made a dramatic shift in its own strategy. The new mission, as NASA leadership puts it, is to stay. The American response is the Artemis program, which has been reshaped into an accelerated effort to establish a permanent human presence at the lunar South Pole, called the Artemis Base Camp. And just like its rival, the plan depends on nuclear power. NASA, in partnership with the Department of Energy, is actively developing a fission surface power (FSP) system, a project to place a 40-kilowatt class nuclear reactor on the lunar surface by 2030. A 40-kilowatt output is enough to continuously power about 30 households for 10 years, providing the energy needed for habitats, rovers, and, most importantly, for mining that precious water ice. In 2022, NASA awarded initial design contracts to teams led by Lockheed Martin, Westinghouse, and others to get the project started. The path to this nuclear base is now being paved by a new 3-phase approach announced in early 2026. Phase 1 is focused on robotic exploration and is already ramping up. Through its Commercial Lunar Payload Services (CLPS) initiative, NASA aims to send a stream of robotic landers to scout the most resource-rich locations for the future base. Phase 2 involves a major restructuring of the crewed missions. The Artemis II mission is still planned to fly 4 astronauts around the Moon in 2026. However, the first human landing of the program has been shifted to Artemis IV, now targeted for 2028. The Artemis III mission, launching in 2027, will now serve as a crucial test flight in Earth orbit to practice docking with the new lunar landers and test new spacesuits. This change is part of an aggressive new schedule that aims for crewed landings every 6 months to rapidly build up experience. This aggressive surface-first timeline has led to a major pivot. NASA has officially paused development of the orbiting Lunar Gateway Station. Instead, funding and hardware once meant for the gateway will now be repurposed for the surface base, a clear sign that a permanent foothold on the Moon itself is the top priority. The final phase, starting in the early 2030s, will see the delivery of the fission surface power reactor, large habitats, and pressurized rovers from international partners. The estimated cost for this ambitious build-out is around $20 billion. By leveraging commercial partners, international collaboration through the Artemis Accords, which now has over 60 signatory nations, and a laser focus on the lunar surface, NASA is mounting a direct and powerful answer to China's challenge. The stakes and future implications why it matters. This race is about so much more than national pride or scientific discovery. The stakes are geopolitical, economic, and strategic, with consequences that will shape our century. Whoever gets there first could gain a massive advantage in this new era. The most obvious stake is resource control. Beyond water ice, the Moon is a potential treasure chest of valuable materials. Some believe the lunar dust contains large amounts of helium-3, a rare material that could be a candidate for clean and powerful nuclear fusion energy on Earth. It may also hold rare Earth elements essential for modern electronics and defense technology. Securing access to these resources could shift global economic and energy markets. It's become a race for prime real estate, with both the US and China aiming for the same few kilometers of the South Pole that offer both sunlight for initial power and access to the dark, icy craters. Then there's the military angle. The moon is considered the ultimate high ground. A permanent base could host advanced sensors for unmatched surveillance of Earth and the space between Earth and the moon. While the 1967 Outer Space Treaty bans weapons of mass destruction on celestial bodies, the line between civilian and military use can be fuzzy. The US Department of Defense has watched China's development of anti-satellite weapons with concern. The fear, expressed by top US officials, is that China's civilian space program could be a cover for a military one, aimed at dominating a domain that's critical for modern communication and warfare. This is also a battle of ideas. The US is building its lunar coalition around the Artemis Accords, a set of principles for transparency and peaceful cooperation in space. China is building its own coalition around the ILRS. Two competing visions for how humanity will operate off-world are taking shape. The side that builds the first permanent base will be in a strong position to set the standards that could become the foundation of future space law. This whole situation is made more intense by a US law called the Wolf Amendment. Passed in 2011, it blocks NASA from cooperating with the Chinese government without special permission from Congress. While it was meant to slow China down, many argue it actually pushed China to become fully independent and build its own rival space program. It has created a deadlock that ensures this new space race is defined by competition, not collaboration. The implications are clear. The nation that first masters nuclear power on the moon won't just control access to lunar resources, it will also hold the key to the future of the solar system, projecting its power and influence for decades. So, here we are. Two global superpowers are locked in a high-tech, high-stakes race to build a nuclear-powered home on another world. The United States, with its revamped Artemis program, is betting on commercial partners and a rapid series of missions to establish a permanent base by the early 2030s. China, with its ILRS project, is steadily moving forward with its long-term plan and a growing list of international partners, aiming for its own nuclear-powered facility by 2035. This is a defining moment. The technologies being created for these bases, from small nuclear reactors to 3D printing with moon dust, will help us learn to live and work sustainably beyond Earth. But this competition also brings risks, raising tensions over resources and territory. The next decade will decide everything. Will these parallel efforts lead to a new Cold War in space, or will they push humanity forward faster than ever? Will the United States succeed in its pivot to a permanent lunar base, or will China's focused, state-driven plan win out? We want to know what you think. Is this intense competition a good thing, or is it a dangerous path? Let us know your thoughts in the comments below. And if you want to stay on top of this unfolding story and get the latest updates on the race back to the moon, make sure to subscribe and hit that notification bell. The future is being built, one launch at a time, and you won't want to miss what happens next.